Okay, hello everybody. So from the design back to engineering. I'm Harri, as introduced, and Sensible 4, we are a software company developing autonomous driving systems for all weather conditions. So basically, the general idea, I mean, most of you probably are from Finland. The weather is always not that nice. Finland, actually, we don't have any natural resources like Norway, like oil, but we have one, which is bad weather in different forms, and Sensible is there to exploit that natural resource in the area of autonomous driving. Okay, so before going into details too much, I wanted to give you a brief landscape of what's actually happening in this area in Finland. I know there's a lot of things happening underground, but these are the sort of public ones. As we don't have an OEM in Finland, we only have assembly plants. It sort of gives us the freedom to focus on the topics we see relevant. And actually, Finland has been, on the public side, we are still one of the most liberal countries in autonomous driving legislation. For a Finn like me, it sounds very, very weird, and it's because in the 70s, the road legislation was written so badly that they forgot to say that the driver has to hold the steering wheel, have a steering wheel. No mention about that. This was actually preventing New York State for autonomous driving a very long time. And they also forgot to mention that the driver has to be physically in the car in the 70s. So we are part of the, the legislation here works in a way that we keep the human as a driver, but the human doesn't have to be in the vehicle. The human can have as many vehicles as we can guarantee the safety, and we can even ask money for the tickets in case of public transportation. So that's why I actually initiated a lot of these public transportation projects back when I was still on the public side. And why I did it is that basically when you're developing autonomous driving, you have two options to what to do. Either you develop driver assistance functions, as was discussed, and slowly climb the ladder up to level 5, holy grail of autonomous driving, or then you focus on shared driverless mobility, which is basically anything else anything which is not owned by the person in the vehicle. Buses, taxis, which we see happening a lot around, shared vehicles, rental cars. So that's where the focus, I think, in Finland is, because it's sort of electrical, efficient, cost-efficient public transportation is something nobody can really argue against. I think what can be argued against is have a same amount of private vehicles, just also driving by themselves to create even more congestion. Okay, moving on Sensible 4, a bit about the team. First I had to admit that we have a terrible team photo. We have now 21 people, company is 14 months old, and we have a sister company, GIM, and altogether I think the headcount today is 37, and we are been hiring developers on bi-weekly status the whole year and expect that this will just grow during this year. I'm the automotive guy. As a startup, we have funny names, but it's really telling about the background. So my background is in automotive, but most importantly, we started to make our robots in 1985 in Aalto University. And this gives you a nice landscape of what has been actually happening in Finland before all the hype of autonomous driving. And not many of you know this, I didn't either, is that the first autonomous vehicle in Finland, or as a part of EU project, but most of the software was coming from here, was developed in early 90s. So Google was established 98, I think, and 93 we were driving on a digital map in something which you could call first generation of level 4 autonomous driving. Well, you see that the back of the car is sort of lower, and that's because it was full of the supercomputers of that time to be able to do that. So there's no copper wire, there is a remote control, but here it's actually following a digital map. Because we are Finland, we have a bad weather, so 2004, project for the Finnish army, that's in Santahamina, maybe some of you have been there in different situation. And this was the same year when the sort of originating of today's autonomous driving hype, the DARPA Grand Challenge was held the first time. And I believe that the first year in DARPA, all the participants failed. Quite many of them self-ignited and everybody else just couldn't complete the lap. And we were not clever enough to get into that competition that year. But this is sort of the background of what's coming from the university. And we believe that the future of autonomous driving, at least for the coming 5 to 10 years, is in the shared driverless mobility. The only problem is that if I would be a fleet operator, so I would be the bus driver company, and I want to invest in a fleet of buses. And the business logic comes that the bus drivers move to the control room, and you reduce the staff costs. I cannot do it if they don't work when the weather gets bad, or if you have, they need to basically have the same uptime as the current level of public transportation. And in autonomous driving, we basically have only 2 problems we need to solve. It sounds very easy. So first one is the traffic. The first rule of autonomous driving is don't break the traffic rules. I think that's the only rule. Because if you don't break them, then in theory you shouldn't cause any risks which may occur to accident. But everybody knows that when there's a bit of traffic and you're coming behind a yield sign, you need to nose dip, which is where you actually break the yield sign. Because if there's traffic and you try to nose dip between the vehicles, you're actually coming behind a yield sign and breaking the rule. So it's quite a challenge in heavy traffic conditions. And the second problem is that whenever you don't have those optimal conditions, the technology should not fail. So where we are today, in CES Las Vegas, the big consumer fair held every year, for some reason all the main autonomous driving developers are in CES these days, and they have demos. And it rains twice per year in Las Vegas. This January it was raining, and practically all the autonomous driving pilots were cancelled. So that's the maturity of the technology. We would have been driving, but we were not there because we were in Lapland, in Muonio. So 200 kilometers north from where the Santa Claus lives, the government has built this sort of intelligent highway, no, it's not a highway, but the intelligent road, where we were testing our autonomous system on a Renault Twizy electric vehicle. And there's a lot of jokes about this car because it's so small, it doesn't have a heating. The doors are sold by Renault as accessory, but the windows are not OEM equipment. So we are always laughing that the team is very, very motivated to get it running on fully autonomous so they don't have to be in the vehicle. So that's from the Salmon Road, which has been on the news. And we basically use it sort of as a test and development area with the idea that we go there to validate the performance in the worst possible conditions. If that's fine, then a little bit of storm here in Helsinki or tropical storm or fog, anything, we should be able to cope safely. What's under the bonnet? The system is running mostly on 3D lidar, which is basically a radar made out of lasers. So there's 16 beams rotating all the time, front and back, and other sensors are supporting that. I will explain shortly what's the logic for different situations. Yeah, I'm a mechanical engineer. I wanted to give you system architecture, but I don't have the knowledge or understanding or time to explain this. But all in all, with huge amount of sensors, you need to sort of see the same phenomenon with few different sensors and try to get system level redundancy and understanding of where you are or what is it that you see in the front of you. If we consider why the Lapland is a good place or why it's so difficult, if you have a normal video camera in the vehicle like this, most of the level 2 or level 1 vehicles have, they are positioning themselves either by looking at the road lanes, well, obviously there's nothing visible, or side of the road, again, nothing visible. Even further, the problem of white color makes image recognition very difficult. If everything is white, it's very difficult from the camera alone to detect anything actually. Darkness, rain, low-hanging sun, all of these are very difficult, and this is actually why I think Tesla is nowadays the only one out of the big ones who is still not using lidar. Everybody else on the like level 4 or 5 developments are using lidar, and this is the reason that you cannot get all the information with the absolute high safety standards we as humans want from just camera alone. This is a good example by Waymo or Google about how the low-hanging sun can make certain things very difficult. You have probably all experienced this, that when the sun is very low, it's impossible to see anything. So there would be 2 traffic lights here on those boxes, but obviously we cannot see them. If we move on, one additional problem is the GPS. You cannot really trust it by itself. This data is from the Lapland because the satellites are in the Central Europe, where you, in average, get better coverage, but in Lapland, the first line is quite okay, but on the way back, terrible signal. And trying to understand from that signal where the road actually is may be challenging. On a lidar, it's also difficult. So on a positioning, typically what's being done, especially on the first generation of autonomous driving products, is that you try to recognize features. You have that box on the upper photo, and you try to recognize sort of corners or lines or walls. And you need to see a few of those buildings or boxes all the time. And then you have sort of relative position towards those features you recognized. Well, it works very well in the city center, where you have buildings. But as we discussed, the traffic may be quite a challenge. And once you get out of the city center, you may not have those boxes visible. No buildings, no navigation. If we use lidar to see our surroundings, we have the seasonal vegetation. Trees fall, trees grow, bushes grow, everything changes. So you need to be very tolerant to changes on your lidar point cloud data. And you need to update it on a regular basis. And the side of the road, which is also was already discussed, you can see it clearly with the lidar, especially if there's some form, but you cannot really use it above level 2 applications. So no real autonomous driving by itself. If you combine it with few other methods, you probably can do it. This is what we've been doing. That's driven around our office in Otaniemi, near Otakaari, and this is a sort of 3D surface presentation of what we see. So we basically, how we drive in Muonio, how we drive here is that we use all the information available. So bushes, buildings, trees, whatever we see, we actually use that for the map. So once you have the positioning, then you have the obstacle detection. And by obstacle, I mean anything which other cars, bicycles, humans, fallen tree, anything which may cause safety risk. Obstacle detection, if you want to be certain about it, you need to combine a set of sensors for that particular use case. Images disturb easily, but with the image-based methods you can easily recognize, classify what you see. So what we actually do, we use image to recognize human, car, and then with the radar and lidar we actually then start tracking and prediction of where they may be going. So that's the general principle of obstacle detection. Combine information to understand what is it that you actually see, and once you do have that knowledge, then you can start to sort of predict the future at least 1 or 2 seconds away, which often is enough in the traffic. And this is sort of problem both coming from hardware as well as software. So there's a lot of hardware development ongoing, and lidars every year or every 3 months, I think there's more planes, more visibility, everything is improving. But the problem is that the data is still as stupid as it was before. So unless you can use the point cloud getting from the lidar efficiently or from the cameras, it's really no use. This is a real-life use case. Actually, if you would go now to Kivistö in Vantaa, that's the blue dot on the bottom is the train station. You can hop in on that Twizy and take a test drive on a public road. And this is how we see the other traffic and humans, and have a set of sort of traffic rules in that Kivistö area. So the red lines are basically marking our lane where we interpret things differently than outside of the red line, and those blue boxes are pedestrian crossings, and whenever you have something else that must be an obstacle. Last issue with autonomous driving is that okay, when it's cold, it's probably slippery. Same applies when it's a lot of water on the ground. So we need to actually, when the car detects from tires that it's slippery, it means that you're already out of your friction potential. So there's no friction left if it's already starting to slip. And humans, what we do if we have any experience on driving on difficult conditions, we actually try to sort of, based on the visual information, estimate, yeah, this corner looks slippery, I should do something. Maybe I slow down, or if I have a rear-wheel driven car, and then I may just speed up, but that's a different topic. So how we solve this problem, it's ultimately a control problem. We don't have a voice for some reason, but this is taken in Muonio. That was our CTO who was testing the control code. We had a rally track there where he first drove as fast as he could in the morning. This was taken in the spring, in the morning when it was still icy. During the day, weather got to +10, so you started to get slush, ice, and even a bit of dry asphalt, a mix of those. And basically we were repeating the same track all over again, tuning the control parameters, and the focus was, of course, on the steering control. So I think this is, at least for me, it was the most coolest testing trip I had so far. I was at some point, he was on the back seat and there was nobody in the front, and he was doing the same rally track and just observing what's happening. The speed here is, I think, up to 36, which in this track was the fastest we dared to go. In Kivistö, you could expect us to drive 30, which is already quite suitable for this kind of operation. Yeah, so I hope you got some understanding of what are the challenges or opportunities for autonomous driving, especially in Finland. We are the only company doing this here publicly at the moment, but I think that's an advantage because the customers are all international, and we have a good reach to them, but we don't have a competition here, which makes things more fluent. Okay, thank you very much.
Thank you. Let's Tuomas and Jonas, welcome back to the stage for some questions and answers.
All right. Maybe we can start with a question from the audience this time. Anybody has a yes? I was told there was a person with a microphone now. There's not. I will be the person with the microphone. Okay.
Thank you very much for the fascinating presentations. My name is Kasmir Jalman. I'm actually an architect, not a software architect, but a traditional one. And I'm currently designing a city district to Tampere, Hiedanranta, which is a new city district for 35,000 inhabitants, making a master plan for it. It has quite ambitious goals for sustainability, kind of forward thinking. It will be ready in 2040, which means that we're basically designing a city which will be operated, or the kind of autonomous vehicles that you are talking about will be operating in there. So my question is that, I mean, now we are of course talking a lot about how these autonomous vehicles are kind of adapting to the existing environment, but how should the future city be designed to kind of be adaptive to these technologies and maybe some even more advanced technologies that maybe we don't even know about yet?
I sort of want to answer this, but
Please.
yeah. So let's for a moment consider current cities first, because this gives you an idea of where the market is going. We are being asked all the time, literally every day, by the cities that what should they do, how should they prepare the infrastructure, and we say that for us as we see that there will be mixed traffic for coming decades with manual and automated driving, for us the answer is very simple. Only put effort in the digital infrastructure. So we don't want to make separate lane for manual car, for buses, for automated buses, because that's in most cases just impossible. But okay, the future of if we build a complete new district from scratch, I would Kalasatama is a good example of small steps taken towards sort of the removal of private vehicle ownership. If you consider rental car business model, sorry this is taking too long, but if you consider it, once you can maybe with the app or some tag or some other way, you can get a car next to your front door, rent it, then maybe you want to drive manually if that's still allowed, but use it for your daily business. Keep your trunk full of your stuff which you have there daily, and once you're done with the use of the vehicle, you just give it up, and it doesn't mean that you need to find a parking spot. You just leave it somewhere and it goes. Right. So do you need to own a car? I don't think so. And do we need to design the future sort of infrastructure based on the private car ownership? I don't think so either.
Yeah, right.
Thank you for a nice answer. Then we have one from the message wall. I'm going to read it. So there used to be a strong emotional side with cars. Will they become boring commodities like a dishwasher?
Well, I think I can talk about that a little bit. It's a little bit a topic I talked about in my presentation, and it's a challenge too, since the actual physical engagement will be gone at levels 5, more or less, when the steering wheel is not there anymore. So you have to treat the interior as a living space, as a living room. It needs to have different function, and the functions are more vehicle specific. So is it boring? I think that's a challenge for user interface designers, interior designers, developers, to create an environment that will be exciting, engaging, but also relaxing if required. And if relaxing equals boring, yes, that might be adjective and direction as well, because there might be a customer base for long haul distances going from like Greater London towards Heathrow, an autonomous car. Maybe they want a relaxing, boring environment. So it will be a challenge, but also case specific.
Thank you.
Move on to another.
Another one about the software instead. So, will there be open source autonomous car software?
Yeah, I'd hope so. As a developer, I'd be very interested.
Well, I see that there will be a lot of open source. I mean, what we use ROS, Robot Operating System, which is a sort of classical open source software everybody in the academia uses. But actually what people don't often know is that Baidu, who has this Apollo program, which is the Chinese sort of consortium trying to build something together in order to go towards automation faster, that's actually a ROS which they just modified. And the idea is that you have a sort of lot of things which are open source within the Apollo program, shared to everybody, but then around that you can also build your own libraries and IPR. And that's actually what we are doing as well, sort of mix.
Right. Okay, yeah, cool. Another question from the audience, maybe. Is there? Let me try and probably meet you out there.
Hey, so I was just wondering, like, what are the best ways to alert users if the system is failing? Because, for example, if it happens too often, you get used to ignoring it. If you do it too less, then, well, there's no point. Yeah.
Well, yeah. So you're probably considering when you're at the car and. Yeah. Well, I think that's a really good question, and I would consider that pretty much similar to the question when during the driving, when we are moving from manual driving to automatic and from automatic to manual driving, the transition needs to be very clear. It needs to be very clear who is like in charge of driving, and I see there's a bit of similarity there. To me, I would say that that's a really tough one, and I don't see like one clear good answer. I don't see any silver bullets. Well, I can only say that it's a design challenge.
Yeah, I would carry on from that, saying like probably some of you read about the Model X crash on the freeway in US, and like the autopilot on screen and with sound alerted the driver. However, the warning was ignored. Well, it's quest because the driver passed away, so it's hard to say like what was the communication like, how did the driver receive or perceive the information in the critical moment, but clearly it was not sufficient, just visual and a sound. So I would say there has to be a third. Maybe the seat reacts the situation, same way like Mercedes has that and other premium automakers. When you accelerate, the seat belt tightens. Obviously this happened with Tesla, but there might be other ways to make the seat design like functionally more engaging, so that actually gives some kind of physical impulse, like a last resort, like wake up.
Can I quickly add on that? This is exactly the reason why Volvo downgraded on the marketing speeches from level 3 to level 2, and why actually, this is my opinion, but I think level 3 should be skipped completely, and quite many are doing level 2.5 with level 4 features, and that's because it's more simple if legally the human driver is the driver all the time until we are really ready to give the control.
Right, right. Another short one?
Yeah, okay. And one more, and then we unfortunately won't have time to go through all the questions, but maybe you can bump into each other later on to discuss those. But the last one is from someone in Kallio, and it asks, when will I be able to hop in an autonomous cab that does not have CO2 emissions and tell it to drive to the pub without colliding to hobos in Kurvi? How far away are we from this personal utopia?
I'm curious, especially
yeah,
what the three of you would estimate.
Yeah. Maybe you, Harri, know better, but I can try to answer something. Yeah, well, this is a both technical and legal question. So if we say that we have a technology to do that, say in 10 years or 20 years, then we need lawyers to do their magic. And, well, I would say 20 years, but how would you?
20 years?
20, yeah.
Well, if you look what Waymo is doing now in California, they have a taxi service which is officially not commercial, but they don't have anybody in. The ODD, so the operational domain is still limited. So that's the drawback, what they do. But the service is like that, and same for us. What we do last district transportation and aim to be commercial in 2020.
Okay.
Yeah.
But from last district to whole area of Greater Helsinki, that's quite a leap, and that's.
Right.
I think we are both speaking the same thing.
Yeah.
All right. Well, that concludes our Q&A. There will be a short break, and then move on to the next.
Yep. Thank you.
All right, thank you.
One more to the speakers.